Okay, talking about React Router and React and routes and URLs and stuff like that. And it's going to be fun. It's going to be great. I'm a little unprepared, less prepared than usual today. I don't have amazing slides. I have a couple that I threw together at the last second, and but I will be running through the code solution to this week's assignment, and it'll be a little bit of some improv in this session. I'll try to make it useful. And as usual, if anyone has any questions, feel free to ask at any point. But yeah, let's get going. So I'll share my screen here, and I'll just double check. Can everyone hear and see me okay?
Yes.
Okay. Cool. And you can see my screen, like my React router screen presentation, right? Okay. Cool. Okay. So React router, that's what we're talking about today. So this is our agenda. We're going to talk about URLs and routes. We're going to talk about URLs and routes. And then we're going to talk about spas. And no, it's not a spa that you get your hair did. It's a single page application. That's what that is. And then we're going to talk about React Router. These are kind of setting the stage for talking about React Router. And then we're going to do some coding. It'll probably be a shorter session than usual today. But yeah, let's get into it. So the first thing I wanted to bring up, this image, the quality isn't great, but the content is good. Important in routing is talking about URLs. So I'm going to give you kind of a basic high-level overview of what a URL is and why we need them and why they become relevant and important in our code. So a URL, you've seen this in your browser when you copy a link to something, that link is a URL. And sometimes they start with www, sometimes they don't. And sometimes they end in .com, sometimes they don't. What does all this mean? So I can kind of break it down here. It's not gibberish. It actually means something. So the first part of a URL is, at least in the web, it's for any website, as far as I know, it's going to be HTTP or HTTPS. And they stand for Hypertext Transfer Protocol. And so like HTML is Hypertext Markup Language. So you're used to writing HTML, Hypertext Markup Language. HTTP is Hypertext Transfer Protocol. So it's the same thing. They're both referring to hypertext. And this is HTTP is the protocol for transferring hypertext across the internet. It's basically it tells the computer, this is the language I'm going to speak when I send you this request or this response, HTTP. And when we're doing fetch in React or JavaScript, we're sending HTTP requests. So it's kind of this way of communicating over the internet for computers. And there's a few different ways that computers can communicate over the internet. One of them is HTTP. HTTPS is just the secured version. So the S, think it stands for secure. That makes sense. It encrypts all the information that gets sent between computers in the network. So that's the difference between HTTP and HTTPS. There's also TCP and UDP and there's a mail one. I can't remember what it is. If anyone knows, feel free to chime in, but different ways of sending information between computers over the internet. That's what that is, HTTP, HTTPS. Then there's the domain and subdomain, and then the top level domain. So the top level domain is .com. It can also be .org or .gov or .something. The top level domain is basically there's a series of computers out there in the world that route your. Actually, before I get too deep into the weeds in this, I just want to kind of say the point of a URL is it's for your computer to communicate with another computer over the internet, and the specific details of which computer you're trying to interact with is defined by the URL. So the URL basically says, I want my computer to talk to this other computer. And the specific other computer in the world that you're talking to in your computer is defined by the URL. And then the specific, what are called resources, which would be like either a website page or like some data from an API or something. The resource is defined after the whole initial part. It's after these slashes. So like /marketing, that would be your computer is going to blog.hubspot.com. There's a specific computer that's associated with this domain name. And then / and then whatever comes after here, still within this same computer, it resolves to the IP address of a computer. And then that computer decides, okay, now you want this specific data here, which could be this subdirectory. This would be either a website page, or in the case of like an API, it could be you're requesting specific data, like marketing data here. And I guess I don't really need to go into depth about the specific types of domains, the subdomain, second level domain, top level domain. Basically, what you need to know about these is google.com, youtube.com, whatever.com, that's the domain. And it has different subdomains, but that's the domain. And the domain gets turned into an IP address. It gets translated like a phone book into an IP address. That IP address is associated with a specific computer out there. And so when you're using the internet, all the communication is done through URLs. It's done through your computer sending requests, HTTP requests, to other computers. The specific computer that it's going to send that request to is defined by the domain. And then the specific information you want comes after that first /. And I could probably show you an example of that just randomly. Let's go to, I don't know, maybe Wikipedia. Maybe I could search like URL on Wikipedia. So I'll click on that. And now if we look up here, this, and on Google Chrome, sometimes the browser will hide part of the URL. I don't know if you can see that there, but until I click on it, until I double click on it, it's actually not showing http://. It's just starting with the domain name. But if you double click, then it'll show the full thing. This is your URL for this specific web page. And if I send this to anyone, their computer can access this same web page because the URL is like the address for this web page. So the first part is this domain, wikipedia.org, or en.wikipedia.org, which I would assume en means English. And then there's this slash wiki slash URL. And just because that's really small, I'm going to copy that here and paste it in here so that you can actually see it. Oh, okay. So by the end of this session, hopefully you see URLs as not being gibberish and you can understand the different parts of them. So en, and I can actually, how about I pull this over too? So we can see the parts of the URL and then we can compare it to the Wikipedia one. So parts of the URL. So this, the scheme, HTTPS, that means it's a web page or something. The language that it's being translated through is HTTP. That's the language of the requests and the responses. This is the domain. So this defines which computer it gets sent to. And that will actually get, there's a servers out there called DNS servers, domain name resolution. And what they do is they're like a phone book. They store all these domains and then the associated IP addresses of the computers. And so your computer will send, when you type in this URL and hit enter, your computer sends a request to a DNS server. That DNS server translates this into an IP address with the server that has the web page. Then it sends that IP address back to your computer, and then your computer inputs the IP address into this part, and then it knows which computer to go to. And actually, you can type in an IP address into a URL, and it'll give you the same thing. Like if I looked up IP address for Google, there's a more like better computery way to figure this stuff out. But let's see. If I enter this, it might bring me to google.com. I haven't tested this out. Oh, no. HTTP. Okay, I'm wrong. Let me try this one. I didn't test this out beforehand, and I'm not like a full expert in all this, but maybe I shouldn't go there. So it's saying it's not secure. That's because it's using HTTP instead of HTTPS. Anyways, I can't really work that right now. There's a way to do it using, yeah, I guess you can type ping. So if I were to go to my terminal here and do ping google.com. Yeah, there we go. So ping, that's a command you can type in Unix or Linux, and it will send a request to the server, to a specific like website server, and it's a way of testing the connection. So ping is like the connection test basically, and it's sending like a tiny bit of data back and forth to test your connection. And it'll tell you, it's a good way of checking your like latency. So it's time 9 point whatever milliseconds, blah, blah, blah milliseconds. So your ping is actually your speed of your internet connection in a way. And so I pinged google.com and then it translated it to this IP address. So if I copied that, if I got that right, I hope, paste that in here, maybe with the HTTPS. Let's try that. HTTPS:// and then this IP address. Oh, shoot. Okay, that looks bad. I should have practiced this beforehand. I've seen other people do it. I've done it at some point, but I can't remember exactly how. Just know the point still stands. IP addresses are the actual server computer that has your website data that you're trying to get, and the domain name is the uh, human readable. It's like what you type in because it's easier to read and write. Okay, so wikipedia.org, and then the important thing we're talking about today is routes, React router, and that is where this part comes in, this end of the URL here. So maybe I'll color that a little different, color it red or blue to match what they had there. So this /wiki URL here, we're going to this website, the server that serves this website, wikipedia.org. So there's a server that just by default serves this website. If you just do that first part, that will bring you to the home page of the website. And if you do it and include that backslash right there, it'll still bring you to the home page of the website. Same thing. And you might know from using, if you've learned a little bit of Linux, you might know like cd blah 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 slash. Like I could do print working directory. This is the path, the file path. And so in computers, the way you represent like files and folders is using a slash to represent a new directory. So we have this directory, then that directory, then that directory. They're all separated by slashes. So a server computer that has a website on it will actually have different web pages in different directories, and you access them using slashes just in the same way. So the home directory would be this, and then you can go to /wiki, and if the web server has a page to represent that, then it'll bring you to that page. And then, so it gets more specific as you go further. So this would be /wiki, and then that's anything in Wikipedia that's /wiki, and then /URL, that would be the resource. So if I typed in something else here, like cat, if I paste this into my web browser, I would assume it'll take me to the Wikipedia page for cat. Yep. So I just looked at it and I saw, okay, wikipedia.org /wiki. I don't know why they have /wiki. Maybe there's other things, but I saw /URL brought me to the page for URL. So I assumed /cat would bring me to the page for cat, and what do you know, it does. So that's how your computer actually is navigating, finding these different websites when you're surfing the internet. And each time you click on a link, that link is actually associated with a specific, you could like copy the link address. And then if I paste that somewhere, do it in Canva, sure. Paste this link. Oh, that's the link for that specific. So if you were to click that link, your browser would actually navigate to this. So your computer is sending GET requests, HTTP GET requests to a server out there, and that server is sending you all the pages that you want based on the end of the URL here. And that is called the route. So this is a route wiki, and then /domestication, that's a route. There's other types of information you can store in the URL, but the one that we're going to talk about today is routes. So /wiki is a route, /cat is a route, and the server that serves up these web pages has routes defined so that when someone's computer sends an HTTPS request to this URL, that server will respond with the specific page that's relevant. Okay, that's something about URLs. Let's move on to routes. Oh, I kind of got it there. So in this diagram, they call it a subdirectory. You could think of that as being a route. So blog.hubspot.com / and anything after that .com would be the route. And one way of navigating through the internet is by typing routes. Like someone might go to my website / blah, blah, blah. And you can actually type their website / blah, blah, blah into your URL, and it'll bring you to that specific page on the website. But it's more easy typically to just use links on a page to navigate. But at the end of the day, it's the same thing. If you click a link to get to a specific route, or you type the route in, it's all the same. Okay, now let's talk about SPAs, single page applications. And after talking about this, you should see why React Router needs to exist. And then hopefully, yeah, hopefully it'll make sense why React Router needs to exist, but then I'll specifically state it. But so SPAs are also called single page applications. And React is a way of making a single page application. And a single page application is basically an app that the entire, it's a website where the entire website is on a single route. It's a single page. And so any React app by default, when you are using it, you're actually, let me think of how to describe this. Single page application. Let's see what Google has to say. A single page application is a website or web application that updates the current page with new data from the server instead of loading new pages. This makes the website feel more like a native app by providing faster transitions. I guess that's a good definition. Dynamically rewrites a current page with new data from the web server instead of the default method of web browser loading entire new pages. So kind of the point is, and I'll see if I can find a diagram to look at while we're talking about this. Sure, this one's good. Okay, so in a traditional website, when your computer is navigating between different tabs, different pages within that website, your computer is sending a HTTP request to the server every time you click on a link to go around to navigate through the page. And when your browser renders new information on the new page, it's because the server sent your computer a new web page, and your computer loaded up all the HTML and CSS and everything again. So if I were to go to a page that is probably that, Stack Overflow probably is that. So if I click on this post, we can imagine our computer is going to send a request to whatever URL is associated with this link. And then the server is going to respond with HTML, CSS, and JavaScript that loads up our page. And it's going to completely re-render the entire DOM, the entire window. Our browser doesn't care about the current page we're on. It just re-renders the entire page based on the whole new web page that the server sent. And I can actually test that out by going to network, and let's throttle it so you can do, I I'm going to throttle it to a 3G connection. So this is like slowing down my Wi-Fi here, or simulating slowing down my Wi-Fi. And if I click on this, we're going to imagine, if I'm right, then the entire page should reload. And we should see it happening slow. Yep. Okay. So it was pretty quick, but the entire page probably reloaded. And we can actually look right here, this reload page thing. If that turns into an X briefly, like right there, yep. So I just navigated back and it turned into an X. That means it's reloading the entire page. I click it again, turns into an X. That means it's reloading the entire page. And so that's fine. But what that ends up in, and again, we're talking about, this is a traditional website. This is how websites have mostly always been done, is you have mostly the same information, but every time you click on a new link, the server is sending you all the same information again. And your browser has to re-render a lot of the same information. Like this top part here, the header, it stays the same no matter what page I'm on. This side part here might stay the same no matter which page I'm on. Basically, there's a lot of things that don't need to be completely re-rendered and transferred back and forth. There's a lot of HTML that gets transferred back and forth that's redundant. It's the same across any page within this website. And so what a single app or a single page application does is it says, I'm going to keep some of this stuff still rendered. And I'm actually just going to, instead of loading up an entire new web page, I'm going to only change the parts of the page that need to be changed. And instead of sending a request to the server to get an entirely new web page, it's getting some chunk of the page. And you can see this here in this diagram. A single page application is reloading a chunk of the page when you send a new request to the server to like load a different page. It's just reloading part of the page. It's not reloading the whole thing. Whereas a multiple page application or a multi-page application, they re-render the entire page every single time. So a multi-page application is more work for the server and it's more work for your computer. Both computers have to do more work and much more data has to get transferred back and forth because you're sending entire web pages back and forth instead of just reloading specific small parts of it. So React solves that. That's one of the fundamental things of React is if I go to a page that I would assume was made with React, like react.dev. Here, if I were to click on any part of the page, I would assume this loading thing will not switch on to mean we're not reloading the entire page. And specific parts of the DOM won't actually change. They won't be reloaded. So if I say learn React, yep. So you can look up here. That doesn't change to an X to mean we don't change the entire web page. This whole top header doesn't change. So I'm navigating back and forth, and it can actually happen much faster because my computer isn't actually having to re-render the entire web page. And another feature of it is when I initially go to react.dev, the server can send me the entire website, every single page of the website all at once. And now to get to different pages on the website, when you click different links, your browser is actually changing the page without sending a new request to the server. And so that is like the default way that React works is your JavaScript on your computer is doing the work of reloading your entire page or of changing all the components on your page. It's not that HTML is getting sent back and forth. So you get some initial amount of HTML with a React app, and then JavaScript takes over and does all the work of rendering and re-rendering components when you change links. And a couple benefits to that are, well, for one, you can selectively reload certain parts of the page and not other parts when you're changing things. Like I can change between these two pages. Most things stay the same. This side part stays the same. The top part stays the same. My computer doesn't need to refetch all the information for the entire website. And another good thing about this is if you, well, it's less work on the server computer. The server has to do less work. It's less work over the internet, takes up less bandwidth. And also, it makes it so if you go out of service, if I were to fully go out of service, but I was on the React site, I could still navigate to different pages. Whereas if I ran out of service on a multi-page application, I wouldn't be able to get those new pages. But in a React app, you're typically going to get the entire website sent to you all at once. And then your computer is storing all the information to make the entire website work. And navigating to different pages is no longer sending HTML between you and the server. It's reloading the page using JavaScript, which is something that React does behind the scenes. So, okay, so that's the difference between a single page application and a multi-page application. Is in a multi-page application, in order to reload the web page, whenever you click on a link, your computer is asking the server computer for an entirely new web page, all new HTML and everything. And it reloads your page, and you can actually tell by looking at this little reload icon. So on Stack Overflow, if I navigate to a different part of the page, say I click users, we can actually see it have the little X right there. It's sending a network request. It's reloading the entire page. So it's more work on my computer and on the server. Whereas on React, if I click a link here, it doesn't reload the entire page. My computer has all the information it needs from the get-go to load every single one of these pages. Now there's one small kind of caveat, which is when I was originally looking up single page application here, you might have seen a website or application that updates the current page with new data from the server instead of loading new pages. So that is one part of it. It can load the page with new data from the server. It doesn't have to. If it is loading the new page with new data from the web server, it's likely that the server is just sending over some JSON data that we're using to reload our page. But it's not sending over the full HTML needed to make the page happen. Okay, so, and now I think you have a better kind of understanding, so I can finish out with this. Here are some advantages of single page applications: quick loading time, seamless user experience, easy to build feature-rich apps, whatever, this is all just jargon. Less bandwidth because you have less data going back and forth between your computer and the server. Smaller application file sizes because you have less repeated HTML and stuff. Some disadvantages of single page applications: they don't perform well with SEO, search engine optimization. So it's not, the different pages are not going to be registered with Google. And so when you search different pages, they're not going to show up well in Google's search engine or other search engines. It uses a lot of browser resources, so more of the work to reload a page or to load new pages is done on your computer rather than the server computer. And security issues, not sure exactly what those would be. You can tell if a website is a spa in the content, or if the content changes without opening a new page. Some examples of spas. Okay. Some frameworks for building spas are React, Vue, all those. Okay. So that's what a single page application is, and React is a single page application, or React builds single page applications where you go to different pages, but they're not entirely new pages in the traditional way. They're just re-rendering parts of your DOM. They're not fetching an entirely new web page in HTML from the server. Okay, we have a question. Could there be any delay during the initial load because the components are rendered all at once? Yes, that is an awesome question. Okay, so the question is, could there be a delay during the initial load because all components are rendered at once? So when your browser gets a React app, when I load a React app, like this one, I assume React's website was made with React. When my browser loads it, it starts off as just an empty HTML file, or mostly empty. And then React results in a bunch of JavaScript, and the JavaScript is actually what fills the browser in, or it fills the DOM in. So React is doing a bunch of stuff behind the scenes to generate JavaScript. The JavaScript is actually what's creating all the components on your screen. And so the question is, when you initially fetch a React app and you're loading all these components on your screen, does that increase load time? And it sure does. And so that is one problem with a single page application like React, is more of the DOM rendering is not in HTML, it's using JavaScript to create DOM elements on your computer once your computer's already received the data. So your browser actually has to create all those elements in JavaScript. And that is definitely a little more work on your computer. It's not too bad. It's not too crazy, but one problem, and it's actually bad for SEO, for search engine optimization, is the fact that when so Google has web crawlers, which basically they're bots that go to different websites and index the pages, and that's what informs the Google's search results. So when you search for something on Google and you want your website to appear closer to the top, the bots that Google has called web crawlers are the things that are actually indexing all the websites in existence, and determining where they go, like how prioritized they are. And a React app will actually do terrible in that regard because the bots aren't going to wait for the JavaScript to actually load all the components of the page. And so when a bot gets to a React site, all the bot sees is an empty HTML file, and then it doesn't give it time to load all the actual elements of your website. So a React app will pretty much look like an empty website to web crawlers. And so that is why something called Next.js exists. Next.js is the React framework for the web. Next.js enables you to create high-quality web applications with the power of React components. And instantly stream UI from the server, integrated with the app router and React Suspense. React Server Components adds components without sending additional client-side JavaScript, built on the latest client and server rendering. So basically, the idea is Next solves the problem of a React app showing up as a blank HTML page that needs JavaScript to load. Next actually renders all the HTML on the server. That is the core benefit of using Next.js. And React recently came out with server components, which are actually turned into HTML on the server, which is a good thing. But it's actually, I think in order to use server components, I'm pretty sure it doesn't make Next.js any less useful. In fact, I think you can only use server components within a specific framework like Next.js. So this Next allows your server to actually render some of the HTML. And you basically decide, and we could see this somewhere in here. I think there's a learn, getting started. You know what? I'm going to go on too much of a tangent. I need to wrap this up. So the idea is Okay, so getting back to URLs and routes, a single page application, when you click on a new link, in order to not send this request to the server to get a bunch new HTML and stuff, what you basically do is you have the links not not send a request at all to the server by default. What they do is they result in different components loading. So you have a link associated with specific components rendering in the page. And then when you click a new link, it reloads different React components. And by default, you can do that on your own, but the problem is it doesn't change your URL. And so you can't link to different pages just from changing components on your page. It doesn't actually change the URL. And if you don't change the URL, then if you're on a specific page and you try to send it to someone, they won't be able to actually reach that page through the URL. So single page applications, kind of the upshot of all this is single page applications don't allow you to, they break URLs. Single page applications make URLs not work right. And so if a URL doesn't work right, then you can't link to the page. You can link to the home page of a website, but if you're clicking around to different parts of the page, if it's just rendering those different pages as different components on your site, but it's not changing the address bar, the URL, then you can't, like I couldn't send this page to someone because it wouldn't have changed the URL. It would just be the default React site. And so that's one thing that React Router solves, is React Router changes your URL for you. And another nice thing about that is you can actually press the back and forth buttons to load different things. Even though it's not actually loading entirely new web pages, it's not actually like sending new requests to the server to get a new page, which is the traditional way. It is allowing you to navigate within different pages in React, in your React app, and load different components to the screen by using these back and forth navigations, by using URLs. You can link to certain pages and it'll render the specific components that are associated with those URLs. So in summary, and let me get one of these. I think I have, yeah, this is better for body text here. In summary, React Router allows, if I can spell it, allows you to render certain components for certain URLs. So you decide which components in your React app are going to load associated with a specific URL or a specific route, which again, the URL contains a couple other things. It contains HTTPS, it contains the domain and the subdomain and the top level domain. The important part is after all that, after the last slash, the route, like marketing, /marketing. So you can have, with the React Router, you can have a URL where each different like /marketing or /whatever, each of those will actually render a different version of your React app where different components are visible. That's what React Router does. And I can actually go to their page. React Router has a website. So we're going to see just kind of the basic idea of how it works. To get started, and ours is going to look a little bit different because we're using a different version of it. And in fact, maybe I'll just go to the one, I think this is the site. You can select the specific version. I think this is the one to get to the version we're on, maybe. I don't know. Though the code that we used, I couldn't find a good example of the way that we're doing it on their website. But so maybe I just won't even use their website. Let's just get to coding. How does everyone feel about that? Let's get to the code. It's been kind of a hectic, all over the place session so far. Yeah, sorry it's been so all over the place today. I didn't prepare very well, but hopefully everyone's getting something out of this. How's everyone feeling about the URLs and routes and stuff? Is that making sense? And single
I
page
can
application.
hardly tell that you didn't prepare because, I mean, you're explaining things so well.
Cool. I'm glad. Okay. Also, if you saw that, that was I have error affirmations here. Let's see, I'll show you. Oh, wait. React to-dos. Get an affirmation. Your mistakes help you learn. Progress, not perfection. These are little affirmations that show up. This is a VS Code extension that I actually made with some of my friends at a boot camp. So if you want our extension, it's called Error Affirmations.
I like it.
And it was just a funny, it was like one of our projects we made. It gives you little notifications every time you open VS Code that have a little affirmation, which is fun.
Sounds very encouraging.
Yeah. Okay. Code. So so we have this app, and I'll start it by running npm run dev. And copy this URL. It might open in your browser automatically, but you can also just copy it, paste it, and there we go. So we have our cats app, our cat list, and you can add a cat and remove a cat, except removing cat no longer works because our data is synced up with Airtable. So we're getting these cats from Airtable now. And I haven't included a remove button no longer removes it in Airtable. I think it removes it on my computer. Yeah. So I can still remove it locally, but if I refresh my page, which remember, that's going to send a new request to the server, which in my case is a server on my own computer. But now we have all the original cats. Okay. So we have our cat app, and we want to add a new route. So I want to be able to go to this URL and do like slash, in this assignment, it's going to be slash new. And that URL will be associated with the form for, I guess, adding a new cat, I would assume. Because right now we have this form, but maybe we'll move that form over to the other one. For today, we're basically just getting the like baseline setup for React Router, which is great because it's great. Okay. So we have our app running. It's our cat app. Let's go to Code the Dreams lesson here and let's walk through how to do it. So open source slash app.jsx. So we're going to your app component, which we're in that right here, app.jsx. It's kind of the main component where everything's happening. Import browser route. Oh, wait. The first thing you have to do is install React Router. I skipped that part, sorry. Install React Router. And I think everyone here is just by default using npm. It says, if you're using npm, run blah, 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 otherwise use yarn add. So npm and yarn, they're alternative things that do the same thing. I think everyone here is using npm. So let's run the npm one. And I have my server running in this terminal. So I'm going to open a different terminal, which you can do that by pressing this plus, open a new terminal. Because this one has to be dedicated to running your server for your app. So this one, I can do commands now. So I'm going to paste that, npm install React Router DOM. What that does is it says, I'm going to go get, so React Router is a third-party package. It's some code that was made by some other people, and it's available on the internet if we want to put it in our project. So far, we've been using only packages that were included in this initial install of our React thing, create React app. This is our first third-party library we're adding. So this is other code, and this is how you install another person's code, is use npm install React Router DOM. So now we have React Router DOM in our page or in our app, and you can check that by going to package.json, and it'll have it right here, React Router DOM under dependencies. Okay, now set up router. Go to source/app.jsx. So let's go to our app.jsx here. Import browser router, routes, and route from React Router DOM. Okay, so we're importing some things from React Router DOM, this new package that we just installed. What are those things? Browser router, routes, and route. And I have an app. It's a Mac app called Flycut that allows you to copy multiple things. So if you're curious, Flycut, clipboard manager. If you're on a Mac, this is very useful. It allows you to copy multiple things and then like go back in your history of the things you've copied. Just so you know. So I'm copying browser router, browser router, routes, and route from React Router DOM, and I can actually copy that too. And then I'm going to go into my app.jsx, and I'm going to add an import for all these things. So import, and the import, if you're importing multiple things, it's likely that it's not a default import, or it's required that it's not a default import. You can, this is a detail. Sometimes your imports are going to have curly braces like this, like how use effect and use state are in curly braces. These are being destructured out of the file here, whereas some of them are just the entire file, or what's called the default export. So in this case, we're doing the curly brackets. So import curly braces, and I'm just gonna go through those things that I copied: browser router, routes, and route from quotes React Router DOM. And don't worry about this last thing here. That's just an app that I have that tells me how big these files are. You shouldn't have this 5 or 15.3K gzipped, whatever. It's just this part that's important. So we're pulling in these things that we're going to use: browser router, route, and routes. Now let's go back here. wrap existing JSX with the browser router component. Okay, so we're going to scroll down. All of this JSX I have here, which isn't a ton, but it's some, we're going to wrap this in a browser router component. So I'm going to make a new component here called browser, if I can spell it, browser router. Actually, it needs to be component. So browser router. Oh, browser router. Lowercase. I don't know what's wrong. Browser. It is uppercase. Okay. Browser router, like that. And then I'm going to open that up, and I'm just going to press Alt and the down arrow to move that closing tag down. Now all my elements are inside of it. And I'm going to let my formatter format it. Okay, so we wrapped all these elements in browser router, this new element. So anything that is wrapped in browser router is now going to be able to be affected by your router. So you basically take this component, browser router, and put it on the furthest back part of your app. The like parent of all parents is where you want this, because anything in your app that is going to be using routing needs to be wrapped in this. So you should pretty much put it at the parent level of everything. I don't know why they had us put it in app.jsx. I would have put it in main.jsx here. But that's fine. We're putting in app.jsx to go with, so we all have the same thing. Okay. Inside the browser router, wrap existing JSX with new routes component. Okay. So same thing, except this time it's a component called routes. Gonna open that up and wrap everything in. So now I have everything in browser router and routes. Inside routes, wrap existing JSX with a new route component. Okay, again, so we're doing 3 different layers where we're wrapping everything in these 3 things. And I got to this yesterday, and then all of a sudden I was getting it, and it says, you're good. Okay, really quick. Add a path equal to the root path, which is the slash. So route should have something called path, an attribute or a property, and that should be equal to strings and then a backslash. And the backslash represents the home route. So with browser router, remember, we're conditionally rendering components based on the route, the URL. And so anything associated with the URL that is just, and the domain of your website is implied. So everything, like if our website was this, localhost, blah, 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 everything here is implied to get to like the actual website. And then the slash, and then the route slash blah, that part is the part that we're worried about in React Router. And so if you remember, I said a slash is the same thing as not having a slash. The slash represents the home route in a router. So not having it and having it is the same thing. It will go to the same place on a server. And so when you just say the path is just a slash, that means this is the home route. So everything on just the default home route will render this, what's inside here. And then it'll say, okay, now go check your code and make sure everything's still working. And it doesn't, it's all broken. And I spent like 15 minutes trying to figure this out last night. I was like, what's going on? What's going wrong? They didn't specify, but this is the solution to that not working. Instead of wrapping everything in route like that, route is actually supposed to have a property called children. And then children is actually where all this stuff goes. So all your JSX for a specific route goes into a prop on that route thing called children. And you use the curly braces so you can escape, which basically means we're passing some code in there, some JSX. So I'm going to copy all this or cut and paste. So I'm going to copy all that and paste it into the children thing. Oh, shoot. I called it children. Sorry. It's not called children. It's called element. I got that wrong. Element. That's the name of the property on route. So it declares an element that should be rendered at a certain URL path. So the path is the home path. The element that will be rendered is our everything, because we're at the parent element of everything on our app. And it looks really crazy and weird. And I'm actually going to delete this closing tag. So it just looks like that. So unfortunately, that's the current state of our JSX. It looks a little bit like a crazy mess, but it's okay. Just remember what's going on is we have the same thing as we had before, except we have everything wrapped in browser router, then routes, then route. And instead of everything going in between the opening and closing tags for route, we're actually passing it into a property on route called element. So our entire app goes in here under this element thing. And if we want, I mean, just to show you what it would look like if we were only passing one element in, it would look like hello, like that. So when you reach this path, render this JSX. And if I went to my site, I should be able to see that. It's not there probably because I have some weird cat background stuff going on that's covering it. But if I went to my, yeah. So there is an H1 here that says hello. It's just not rendering because I have this crazy cat thing going on. It has to do with Z indexes. I have everything on top of this image. So I have to do a Z index for things to show up. Actually, I have to put it in name. Anything in name. Anyways, so that's what we need. We need to wrap everything in this browser router routes and route, and then into the route element prop. And then now our app should do the exact same thing as it was doing before. Now we have our home route, where on our home route, which slash, we can even put the slash and then press enter and it deletes it because it's the same on the home route having a slash and not having a slash. On the home route, it's rendering our normal app, everything how it was. Blah, 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 blah. None of that matters really. I mean, it's good to read, but this is not anything that applies to us really. It's just talking about the React Router 5, v5 used to be different. Okay, run your application and view in the browser, verify that your to-do list appears correctly. It does. Okay, so now we can add a new route. So in the same file, app.jsx, we're going to add a new route. So we added the home route, which is the same. It renders the default site that we've been using all along. Now we're going to add a new route that's going to render something different. So below the route component, create a new route with the path /new. Okay, create a new route, or below the one that we just made, create a new route with the path of /new. So we have a route right here. Underneath that, I'm going to make a new route. And it can be a self-closing tag like that. It's going to have a path equal to /new. And that correlates with, remember, like from this URL thing, that would correlate with blah, 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 whatever domain our React app is hosted on, /new. That's what that route would be associated with, the URL that has our domain /new. Okay, when we get to /new, what do we want to do? Inside the route component, create a level 1 heading with the text new to-do list. And remember, we're not putting it inside the component. They should have specified that in the instructions, I think. But unless someone else knows a way of getting it to work when it is inside the route component, from what I saw, you need to pass it into the element prop. But we want to render a level 1 heading with the text new to-do list. So you say element, and now associated with the URL that ends in /new, we want to render whatever goes in here. It's going to be a new h1 that says new cat list. New cat list. And that should be it. So now when we're on the home route, it should load this. It should load anything that was passed into this element thing here. When we're on the new path, the new route, we should load just this. And I could try that out. Really quick, what I'm probably going to want to do, don't do this if you're not me. I need to do this because I have all that crazy fancy cat stuff floating around the screen and the background image and everything. I need to put my thing here in a main component. That's just me. That's not you. That's because I have z indexes set on stuff, and it won't show if I don't do that. But you should be able to do /new now, and it'll render those components. /new, and you can see now new cat list. That is this text right here. If I just did, I could test it out by doing that. There it is. So now on /new, this route, we're rendering the main and this h1. And in your case, it should just be the h1. It's just if I do it, I have like z indexes set wrong. So I would have to go like into my CSS and do like h1 z index 10. Does it show now? No, it doesn't.
Maybe it's the other way around. Maybe the lowest z index is the one that stays on top. I don't remember exactly.
No, it should be the higher one. I think it could be that I put it in the wrong CSS file. It also has to do with like if you have something, wait, what is the z index of my? Anyways, I don't want to get distracted by that because really what I'm doing is I'm fighting with the fact that I have all this crazy cat magic going on, which
It's all good. We already saw your header level 1.
okay. That's it. Honestly, that's all it is. That's all the assignment is today, is basically just setting up that one path. So at the end of it, it should look something like this. So step 1 is you import React Router, specifically React Router DOM, which is like a variant of React Router that works specifically for websites. And then import these things, browser router, routes, and route, and then set it up to look like this, where each route has a path, and the path you can think of as being the end of your URL. And so now it'll make it so that when you change your URL, it will render different components that are associated with that new URL. And then the next step will eventually be adding links, because who wants to navigate by typing things into their URL? That's not very useful for most people on the internet, because they don't even know what kind of things they can type in that will result in a new page. So for now, this is how we're navigating, is using the URL like that manually. But eventually we're going to make it so that you can click on links to get to certain pages. You can still use the back and forward buttons. When you change the URL, it does that. And that's it. That's all. How's everyone feeling? Any questions?
This really helped a bunch. I don't know if you happen to have any more time now to maybe help us with another one of the stretch goals from the previous lesson, like adding a delete function to the API, or if that would take too long.
I'm happy to try it. Sure. Yeah, I have some extra time.
Okay,
Yeah.
cool. That would be really cool because right now, like my delete button or remove button, it only removes from the local data, but it doesn't remove any to-dos from my Airtable API.
Yeah. I think, yeah, that's how mine, yeah, I didn't add that yet. I think, I don't think I don't think that was a stretch goal on the last assignment.
Oh, that wasn't? I thought it was.
The stretch goal was adding a post, so creating new to-dos.
I thought there was more
Um,
than one stretch goal in there. I could be wrong.
I could be missing it. Maybe there is. But either way, it's something that our app definitely needs. Like if it was going to be a real app, it would definitely need that. So either way, I'm happy to do it because we're going to want to do that. So I
Cool.
can show you how to do it.
Thank you.
Okay, so we currently are fetching cats using this function. This fetches cats from Airtable. This function here, which I made kind of at the end of my session last time, it was a little last minute. I pretty much closed out the session and then I was like, actually, let's go for it. So you can always rewatch the video if anyone wants to. I added this add cat thing. It's mostly the same. Fetching the cats from Airtable and adding cats to Airtable is very similar. You're specifying options, a URL to do the action, and you have a try and catch, which the try and catch is for error handling. You're doing a fetch. Here you're defining the options in URL. Here you're doing the fetch. So both, and I know it looks like kind of crazy because I can shrink these down. So add cat, fetch data, they're mostly the same. The key difference is that in add cat, our options for our HTTP request has to look a little bit different. We have to include a body in the HTTP request where we send over the new cat title. So, okay, so that's how that looks. I'm gonna say for deleting a cat, we're probably gonna want something that looks pretty similar to these two. So I'll just copy, add cat, paste it, and go from there. How about remove cat is a function that we have already that removes cats just from the state in React. So it filters through the existing. So remove cat gets passed in an ID, which at some point we pass, this is like a callback handler function that we send down to our cat list, and our cat list sends it to wherever. At some point, one of our components is in charge of calling this function, and it passes in the ID of the cat that needs to be removed. And then with that ID, we can filter the cats to include all cats except for the one whose ID is the one that we want to remove. And then we just set the new cat list locally in our state to a version of itself that has that one cat filtered out. So that's the way we're solving it currently.
Okay.
We probably want to change this now. We want to change it to work with Airtable. So let's go to the Airtable API thing. I'll go to my cool base, which is where I'm storing my cats here. And then I think if I go to help, API documentation, we'll probably find somewhere in here how to remove, I would assume.
I think
Okay.
if you click on Control F or Command F and search for endpoints, like it might take you to a remove endpoint. Oh, there's one for delete record right there.
Yeah, there it is. And just so everyone knows, like in a like an app like this, it might seem like, oh, there's all these different things you can add. You can add cats, you can get the list of cats, you can delete cats. What else can you do? Well, there's kind of four main operations that you're going to do with data in general. They're called the CRUD operations. CRUD. I know it's a funny way to say it, but create, read, update, delete. Create, read, update, and delete. Those are pretty much the only things you need to do to data, to any data in any app. Like any database, it has a way to create new entries in your database. Read, which means like getting entries, like saying, I want to get these things. Updating existing entries or deleting entries. If you can create, read, update, and delete, then you have a CRUD app, and it basically does all the basic operations you'd need to do to any data ever. There's a couple other like small details about it, but every like API you make, every app that has some sort of like to do or any sort of resource that you can have users add, like a Facebook post or something like that, you always pretty much want to have a way for people to create, read, update, and delete. And each of those has an HTTP verb associated with it. So create, the HTTP verb would be post. Read, the HTTP verb would be get. Update, it would be patch or put, which those are kind of weird ones, but for updating, you can do put or patch. I kind of forget which one is which. Oh, you can also do upsert, which upsert is basically update if it exists. If it doesn't exist, then insert it. And I don't know if I would call that part of update or part of create. It's kind of, I guess, part of create maybe. Post/upsert. And then delete is just delete, I think. HTTP delete. It is delete. Okay. So this is telling me it is delete. The delete operation removes or deletes the current representation of the target resource given by a URL. I'm not gonna, okay. Cool. So to delete records, issue a delete request to the default endpoint. Note that the table names and data IDs can be used interchangeably. Using table IDs means the name changes do not require modifications to your API request. Your table should include a URL, encoded array of up to 10 record IDs to delete. Oh, okay. So you can delete. Oh, that's if you're deleting using just a URL. Or using curl, which is, oh, we can switch this from curl to JavaScript. Okay, that's cool. So curl, this is a command line utility for bash or for Linux commands. So this is how you do something on the command line. This is like fetch for the command line, basically. So in your terminal, you could be doing fetch stuff. We want to switch this to JavaScript. Okay. Oh, and they have their own SDK, which we're not using. We're using fetch. So it could be a little
You
different.
can grab the URL from the curl example there, because that's going to be sort of like the URL that we send to fetch, more or less.
Yeah.
Which I think is pretty much the same URL that we're sending now, except it's going to end with /default.
I think the URL is gonna, yeah, I'm gonna try to do this without needing their docs because I think it's gonna look mostly the same. So I'm just gonna try it out.
Okay.
I'm gonna say what we're gonna do is we're gonna send a delete request. So I'm gonna have options. These are our fetch options. So this is getting passed into our fetch right here. We're passing in a URL, we're passing options. I think the URL is probably gonna stay the same. I think the URL is going to stay the same because the URL isn't specifying, well,
I think it just add a /default to the end of the URL.
yeah. Yeah, maybe. Let's see. Default endpoint /default. Table names and table IDs can be used interchangeably. Use the table IDs means the name changes do not require modification to your API request. Your request should include a URL encoded array of up to 10 record IDs to delete. Data / URL encode records equals blah. I'm guessing we're going to send in the body this records thing. And this records thing is going to include IDs to delete.
Okay.
Let's try it. Records and actually, one thing I could do is I could ask ChatGPT or Gemini to translate this curl command into a fetch request.
It can do that?
Probably.
That's cool.
Translate this curl request into work smarter, not harder, right?
Uh-huh.
The method is delete. The URL is blah, blah, blah /default. This points to the Airtable API endpoint. Here is the base ID and default is the table name or ID. Headers, authorization, body encoded using G flag. Data, okay. Encodes a parameter named records with a value containing the record ID. It didn't actually turn this into JavaScript. Please write a JavaScript fetch request for performing that action. Okay. Method delete, we got that. Authorization, that's all going to stay the same. That looks a little different, but that is probably worth noting. Body new URL search params. Oh,
Yeah, it uses just a form, not a JSON option. As for me, JSON option is like more transparent, at least in using inside JavaScript, and when you don't have explicit form.
oh, okay.
Yeah, see, it uses like a form, and that's why we need that search params, map, blah, blah, blah. And when we use content type as application JSON, we can just propagate a JSON, and that's all.
Okay. That makes sense. So traditionally you would send the request through a JavaScript form.
Yeah, like there are options, yeah, but in context of JavaScript, I think just using JSON will be more suitable one.
Okay. So you think I could just turn this into application/JSON
Then you need to change the body.
to JSON.stringify?
Yep.
Yeah.
You can just ask Gemini just
Yeah.
to use application JSON.
Yep. Okay. So application JSON and then JSON.stringify and then records and records.
Yeah, see,
is
just simple JSON. Yeah. But this won't work if you want to send a file, not a binary one, like the physical file. Then you need to use form
Oh, interesting.
application type. Yeah.
Okay.
Or you can just use a binary option when you just switch that file into binary form and send it in binary. Yeah, but I don't know if we can use like if we can send files to Airtables.
Yeah. Well, for now, I think content type application.json or application/JSON. I think that's going to work. And then this. And then I'm thinking for right now, I'm going to take this part out and that part out, and I'm just going to console log data and we'll see what happens.
Okay.
And I'm also going to have to make sure that I pass in the right cat. Oh, actually I have to change this to remove cat. Remove cat and make sure that, okay, so that's already called remove cat. So I'm going to delete remove cat here. And since this new function has the same call signature, which is, it has the same um, parameters, it should work the same. Or it should be able to be called in the same way as the last one was. So, and I'll just make sure when a cat list item has a remove button, I think, right? On click, remove cat with the correct ID, passes in that ID, and then remove cat, takes in the cat ID. The ID gets sent in the fetch request, and we expect Airtable should remove the cat. And we're not going to update our local state yet. It won't be updated locally yet, but if we reload the page, we should be able to see, or if we just check on Airtable. So let's see, where's our app? It's right here. Let's try it out. Okay, I'm going to delete cool cat, and it probably won't do anything yet. And maybe I'll open my console to make sure. Okay, didn't work. Unprocessable content. 422. Okay, I think that happened last time. I think it's because we need to do JSON.stringify this, right? Let's try that again. Oh, I might have set this to, yeah, throttling. No throttling, please. So that's a way of testing your website with a slower connection. But I want to turn that off now. Okay. Cool cat, let's remove it. Okay, still not okay. If I go to my network tab, I might be able to find more information. Invalid records. Records must be an array of up to 10 record IDs. Okay. Records, a stringified array with a cat ID. Let's see what the cat ID is. Let's make sure that's just coming through at least. Okay, so we are getting a cat ID right there. That's good. Maybe we don't. Oh, we're doing JSON.stringify twice. I definitely don't need that there then. In that case, I'm not sure exactly. Let's compare it to what JSON.stringify and then records like that. And records is an array of strings. Array cat ID should be a string. Content type application.json. Content type application or slash JSON. Delete, did I spell that right? Okay. I'll look up, we'll do some troubleshooting together. Maybe the first step is ask Gemini. Copy that function. What is wrong here? Why am I getting a 422 error? There are two potential reasons why you might be getting a 422 error with your remove cat function, incorrect record format. The records array and your request body currently only contains the cat ID itself. Airtable expects the record ID to be wrapped in an object with a key named ID. Oh, okay. So we're just passing in an array for records. We're passing in an array with an ID, but it's saying we want an object with a property of ID and then the ID. So let's try that. So this cat ID here should actually be in an object. The property is called ID. The value is cat ID, or the key is ID. The value is cat ID. Let's try that. Shoot, it's still wrong. Okay.
Can I suggest?
Yeah, please do.
Yeah. Usually when you delete something, like in a CRUD common usage, you just pass it with a slash. So you have a resource name slash ID of the resource you want to delete, and you send a delete method.
Yeah, that's true. Yeah, we could try that. So like on the URL here, we would add like,
Actually, we have that URL. It's like a copy paste. We can extract it to the like base URL variable and then just add it. Because I believe we have the same URL for all the operations for this default like table name.
this URL here is copied from my my other things. Is that what you're? Sorry,
Yeah, like for remove cat, we have this URL slash cat ID. For adding cat, we have just this URL. For getting cat, we have this URL slash ID. So we can extract this URL like a base one, and then just tune it according to the action. Yeah, but if we have only remove cat here, it can be done in this way. Just make it simple.
you're talking about the base URL. Are you saying like I should change what this is?
Yeah, because like here we have only remove cat, but if we have in this file, if we have remove cat, add cat, and read cat, the URL will be the same with a little tuning at the end. And in that way, you can just extract the base URL. Yeah, but if we have only remove cats
Oh,
here,
okay. You're
then
saying store this as a separate variable.
yeah,
Somewhere else. Okay, yeah,
yeah. It will help us in the future
that's
when
true.
we add like other operations with the cat.
Yep, that's true. Okay, so our base URL is going to be this. And then in our other things that use that,
Yeah.
we can just
Exactly,
say
exactly.
pass in our base URL into those other fetches. Yep.
And for fetch, yeah, we can if we fetch the one, we can just add the slash, and here we can as well we can just add the slash ID for deleting. Yeah.
So we're going to take the base URL, which again is the same as it was before. It's just I'm storing it in a separate variable, which is nice because then we can propagate it throughout the other functions in the app. And I'm going to adjust it here. So I'm adding slash and then the ID of the cat. And then I'm just going to send a delete request with no body. And we're going to try it out and see if that works. So, because that is typical in REST. If it's
Yeah.
a REST API and it's following traditional REST conventions, we should be able to do slash and then the ID of the resource and send a delete request and it should delete it. So
Yep.
it did it. Okay. So the cat is still here. And the reason is because it didn't in my React app, I haven't deleted it. It did delete it in
Yeah.
Airtable.
We need to remove them from local storage.
It's
And
actually not storing them in local storage anymore, at
No,
least on
not?
my app.
Then just
If I
update.
refresh the page,
Yeah.
it'll get rid of cool cat. Yep. So cool cat is
Mhm.
gone. Now if I delete new cat and then I refresh the page, new cat is gone. Yep. So this is actually deleting cats. So that's deleting them in Airtable. And if I went to Airtable, I should see now I only have those 4, whereas before I had more.
Very nice.
Thank you for helping with that, Anton.
Yeah,
You definitely
of course.
saved the day there with the good call. So now we're deleting cats in Airtable. How do we, if we try the fetch, the response is okay, lets us know we successfully deleted the cat. The data, well, the data, as we have seen we briefly noticed it in the console. Our data looks like an object that has like, okay, cool cat too. Let me delete that one. The data looks like this. This is our data. We're console logging it out there. So the data is an object that has deleted true and then the ID of the deleted cat. So once we've verified that we successfully deleted the cat, we can get the ID of the deleted cat, which we already had it. I mean, we could say like if data dot deleted is not true, then we can throw a new error. And call the error something like cat not deleted for some reason. Shrug. So I don't know why. So they send us back this object and it says deleted true. If we get to this point and it hasn't errored out yet, I don't know why we would ever receive an object that says deleted false. Maybe we would have like something in our error table that, like maybe Airtable has a way of like restricting the things that you can delete or something, and we would get something, an object that says deleted false. If that happens, we're going to throw an error. If deleted is true, then at that point, I've done multiple error checks. I've rechecked if the response is okay, which says, did we connect to the server correctly? And did the server not give us like was the URL correct? Was our authentication correct and all that? Did the object get deleted? Yes, it did. If we got to here, to this point, then we are good. We deleted the cat successfully. And so now we want to delete it from our local cat variable. Cat list, which is an array with cats. And I can just do the same thing that I did last time, where I can do set cat list. This is the setter for our state, and use state. We have use state, or we have cat list and set cat list. Set cat list we can use to set it to a new cat list. We're going to pass in one of those updater functions with the cat list. Previous cat list. OUS, previous cat list. An arrow function that, given that previous cat list, we can take it. We can do a dot filter on it. And we can filter it. So we can return a version of it where each cat dot ID has to not be equal to the data dot ID, which is the ID of the cat that we just deleted. One big long line of code. Let's see if this works. What it should do, what I'm expecting, is we set the cat list to a version of itself using this updater function. So whatever this updater function returns, the updater function gets the current state of the cat list, which we're calling previous cat list. The previous cat list is being filtered so that each cat is included in the new array if the ID of that cat isn't equal to the ID of the data.id, which is the cat ID that just got deleted. So only the cat ID that just got deleted, only that cat should not be included in this new version of our cat list. Let's try it out. Oh, I don't want to delete any of these cats because I like all the names so much. Let's delete Drew Harrymore. It worked.
That looks great.
Okay.
Do we
Did
have
it.
it deleted in error tables as well? Just to be sure.
Yeah, we can double check that. Yep.
Yeah. Great.
Awesome.
Okay, so
Very
that
cool.
is the new version of, or that's how to remove a cat, a little bonus. And man, everyone who's still here, power to you. I'm glad you're like going above and beyond, you know.
Thank you for guiding us through all of that. You've been awesome throughout this whole course.
I'm
Yeah,
glad.
Rio, it's everything because of you. That's why so many people are still here. So yeah,
Well,
thanks.
I appreciate it. Yeah, you all are doing great, and it's fun doing this. I always enjoy it, and you all are awesome, and yeah, learning to code and cruising through it. And so, good job, everyone. Give yourself a pat on the back. I will be uploading this code and the recording and this. I won't do the slides. The slides are bad this week, but yeah, you can see this code and the recording and all that. So yeah, good job, everyone. Thank you, and I'll see you next week.
Thank you. I certainly couldn't do this course without you. See you next week.
Thanks a
Okay.
lot. Yeah, bye-bye.
Bye.
Bye.